That one up really nice, where you can just read it now, you couldn't read it.
Well, when they come back.
All that green stuff. Those old, they're like a slab.
Right, hello again. I think we are all ready for our exciting guest speaker tonight. I'm going to let him introduce himself because he has a lot of background and a lot of knowledge on a lot of different things. And without further ado, here is Mike Kudish.
How far away from this? Looks like a licorice lollipop. How far away? Am I okay?
That's
All right. Let me introduce myself for a few minutes and then tell you what I'm going to do. My name is Mike Kudish. I used to teach. Paulson. How far back? How far close? Wait, I hear a lot of echoes. I used to teach at Paul Smith College in the Adirondacks in the forestry division for 34 years and moved to the Catskills 2005, where I'm staying now in Arkville, which is Delaware County town of Middletown. And I'm trained as a botanist, but have gone into forest history subsequently. So I like to call myself a forest historian. That is, I study the history of forests, but that takes a lot of material in it, as you'll see. And one of the big projects I've been working on for the last 25 years has been on the bogs. And I think I'd rather wait until I get to the slideshow to tell you why study bogs, what we can learn from them, and how much we know about the history of the Catskills from the bogs that we would never know if we didn't study the bogs. So I have a whole bunch of things to mention. I do want to give you a general presentation, which I've done before last year in March of the Jefferson Historical Society, and it was repeated in Sullivan County Community College. But today is a bit different because I've tacked on at the end, and I hope I don't go too long, is I've studied only one bog in Schoharie County. Oh, I'm sure there'll be more, but so far just one. And I put on an addendum to today's lecture that's never been presented before. I put together those posters, those charts with some detail. I don't have any old slides from them because that's all relatively new information, and I stopped taking slides about 2009. So I'm just a retired forestry professor from a college, retired to the Catskills, where I can study the history of the forests full time, rather than just coming down here for a month each year when classes were out and continuing. So let's see. This is where I get really nervous. It's, will the bulb light? And if the bulb lights, we're in good shape. If it isn't, there are two backup possibilities. One of them is to try to get a spare bulb in, and the other backup is I have an even older projector in my car. This is my dad's next to oldest projector. I think he purchased it in about 1960s. These Kodak carousels were the latest thing at that time. So this thing's about 60 years old, and the projector I have in my car is even older. It probably dates back to the 1950s. And if you see how it operates, you'll see why it's called a slide projector. So let me put this down. Oh, the big moment. The big moment. I've been nervous about this for a month.
You can have one,
Thank goodness. Okay, now, let's see. Where's my, oh, I don't have a control. Oh, it's okay, I can do it from here. Ah, too low, and maybe a little further back.
You can move that table back if you want.
What?
Move the table back?
Well, we could. Maybe lift up the projector. Whoops.
Very good.
I need a graduate student to hold that poster. Oh, thank you.
Everybody see that? More?
A little bit more, all the way to the top. I have a, that's great.
It's gonna get very tired.
Stay right there.
Still, that's for
Tim, you got
your
something?
arms. I don't know how to work. I don't know if
No, I haven't turned it on.
Good.
If you just move those and then.
Focus? Is it focus? My eyes aren't that good.
Yeah, all right.
It's good.
My eyes aren't that.
All I see is people's heads.
I think it needs to be tipped.
Well, that's about as high as it can get.
Yeah, that's good right there. Arm under there.
That's about as high as it can get. Well, if you can't see and you want to see,
Step on up.
there's no reason why you can't bring a chair up here.
Yeah, there's lots of chairs up here.
Let me start from the beginning. Oh, this is my pointer, which has some historical significance. This is what ski poles used to be like in the 1960s. This came from Hunter Mountain. My dad found it on one of the ski slopes. Simply a wound up bamboo pole, but I've been using it for decades for a pointer. I've got an elaborate display here of materials to show you. So I'm trying to keep this running. I'm trying to get done by 2:10 or so if I can do it. Try to stay within the 55-minute college lecture limit that we have. Anyway, here's Plateau Mountain, Catskills, Spruce Fir Forest, and I'm hearing this boom, boom, boom behind me. Do you hear that? Does that bother you?
No.
If you don't hear it, then that's okay. It's not important that I hear it. My thesis, my dissertation was on the Catskills when I was a graduate student at ESF, which is the New York State College of Forestry at Syracuse. And my thesis was on the forest history of the Catskills. What that really amounts to is that I've been studying it for 55 years, and I still consider myself an old graduate student who can't get his thesis done. Although ESF granted the degree, and I was able to get on and teach at Paul Smith, I still was never satisfied with what I had done in 3.5 years at Syracuse. So I've been working on it all my life. And the box study started about 1994, 1995. Anyway, let me tell you why my thesis started in the first place on a vegetational history of the Catskill High Peaks. This is a spruce fir forest on top of Plateau Mountain. And this is a balsam fir forest on top of Balsam Lake Mountain with a fire tower. So you have summits with spruce and fir forests. You have summits in the Catskills that have balsam fir without the spruce. You have summits in the Catskills that have neither spruce nor balsam fir. This is Dry Brook Ridge right up behind my house, and that's what we call a ridge hardwood forests. It's no conifers, no evergreens. It's primarily red maple, yellow birch, beech, and black cherry. And then we have this, which is just the interior of a sugar maple beech northern hardwoods forest. Some of the summits have that. There's a young lady here for scale. I don't know if you can see her. And these are really ancient sugar maples, and she's dwarfed by them. She was an ecologist at the time. And then we have summits such as Choke and High Point, which is dominated by northern red oak. So I would go from mountain to mountain exploring, just like any hiker would, but looking at the forest and saying, why does this summit over here have spruce and fir? This one has fir. This one has neither. This one is northern hardwoods with sugar maple. This one is ridge hardwoods without sugar maple. This one is oak. And the mountains can be within a mile or two of each other and almost all at the same elevation with very similar climate, almost identical climate, and maybe some subtle differences in soils. So that was my thesis. It took me, the thesis couldn't solve the problem. It took me until probably 20 years ago, figured out why. The reason is every species of tree has a different reason. That's what took so long to figure it out. And that's not primarily what I'm going to talk about today. I just really want to emphasize the bog. Because if I got into why all these summits are different, that's about a 4-hour college course. Okay, one way to get history. from the time I did my thesis, which would have been 1969 and 1971, up to the bog study, which would be 1995, I had two ways of reconstructing history of the forest. One of them would be through tree rings. I don't know how well you can see this. I can try to focus it. This is a stump of balsam fir cut over at Paul Smith College where I used to teach. And if you were up close and looked at this photo, you would see that there are rings, and each ring is a year's growth, so you can figure out not only how old this tree was when it was cut, but also when it had good years, when it had bad years, and in other words, it records its own life history for you. The other way of getting information on the history of the forests would be by using published materials. Now, this is something where I have to admit a weakness, and you people are going to fill a gap, and I hope not very long. I don't have much written history on Schoharie County in my files. My home libraries, and yeah, I have two of them, I've got a lot of stuff on the history of Delaware County, Greene County, Sullivan County, Ulster County. But I'm still yet to really start a good, real rich library on Schoharie. So hopefully you people will be filling that gap in the near future, as well as the folks over at Jefferson and the folks at the Gilboa Museum. So another way is published histories, history of Ulster County, history of Delaware County, history of Greene County, and other old atlases like the old Beers atlases, published items. Also speaking with people who were around a long time before you. My mentor was Ed West, who was superintendent of land acquisition for the state of New York. I learned a lot from him. So there are ways of learning about the forests, but when you hear what happened when the bogs came in, and that just changed everything. Click. Okay. Focus. My eyes won't focus, so is that good?
That's
I
good.
have to put my glasses on and take them off. This is Heart Lake in the Adirondacks. And I just threw this in more as a reminder of what to tell you, rather than any detail going on here in this session on this dock. And what it reminded me of is that back in the 1970s and 80s, when I was teaching at Paul Smith College, when classes were out in the summer, there would be some graduate students moving in from other universities who would use the teaching labs because our students were gone for the summer. They would use the teaching labs. And one of the projects was done by a group of graduate students from different colleges. They were reconstructing the history of the vegetation of the Adirondacks by pulling peat samples out of bogs and sediment samples out of lakes and going through these samples and pulling out the plant fossils and animal fossils, where they could get, and identifying them and then radiocarbon dating. And that gave me an idea. These people are reconstructing the history of the Adirondack forests, going back to the end of the Ice Age, by the use of what we call macrofossils, that is, fossils that are big enough to be seen with the naked eye, not pollen and spores, which are microfossils, but the macrofossils, which would be things like what I have in here, cones, and pieces of charcoal, and seeds, and bark, and twigs, and needles, and leaves, macrofossils, fossils big enough so you can see them with the unaided eye. If these people could do this for the Adirondacks, could I do it to the Catskills? So that's what I set out to do in 1995. And I remember pulling some peat samples out with a shovel. I didn't bring a shovel with me today because you all know what a shovel looks like. But I did bring my peat core. And I remember when the first radiocarbon date came in from one of the bogs on top of Balsam Lake Mountain, the town of Hardenburg, which would be Ulster County. And I got a radiocarbon date of 5,000 years. And I remember what happened that day. I was standing in the faculty office because in those days, the reports from radiocarbon dates were coming through the Postal Service. And there was no email yet. I remember opening up that thing and reading a report from the laboratory in Florida, 5,000 years. And I just stood there with my mouth wide open for about 10 minutes. Some of the faculty members, Mike, what's the matter with you? Why are you looking like that? 5,000 years. I thought maybe 1,000 at the most. Well, it turns out that 5,000 is just a drop in the bucket. Wait till you hear about your own Conesville bog, which I call the Bull Hill bog. at 14,800. How do you like that? So these people up in the Adirondacks gave me an inspiration. Whoops, I can't focus. I hope that's clear. To start studying the bogs, because up to that time, I could go back only 300 or 400 years. That is up to the time before I started studying bogs. I could use tree rings for the oldest trees. The oldest trees are about 300 years. I could use published materials, but I couldn't go back more than about 300, 400 years. And I needed to go back to the end of the Ice Age, which I've been able to do. Thank goodness for bogs. Okay, what's a bog? Well, there are different kinds of wetlands. This is Yankeetown Pond, this is a marsh. First of all, I got 4 kinds of bogs, 4 kinds of peatlands, and I got a chart here. I don't know how, but if anyone wanted to study it, we could study it later. On the different kinds of wetlands. Wetlands can be, would you get in there? Thank you. Wetlands, whoops. I'll bet before the afternoon is out, I'm going to derail on one of these cords and you'll hear a crash, and you'll need the record crane to come pick me up and continue the lecture. It's always a bit of spikes when I'm down on the floor with the little wires. Anyway, a peatland is a kind of a wetland where the peat accumulates and accumulates and accumulates. What is peat? P-E-A-T. It's dead plants. Some animals, mostly dead vegetation, which rots only very slowly, hardly at all, and accumulates. And in that peat, you can have plant fossils which get buried and do not, or barely rot. They can be identified, they can be studied, they can be radiocarbon dated. So we have to have a peatland. A marsh like this one is not a peatland. If you were to dig down there, you might go down 6 inches or a foot, and then underneath the dead vegetation, you would find a glacial till or rock or sand or gravel or clay. And you really need deeper peat, at least a foot, more like 2 or 3 feet, to really get good history and good radiocarbon dates. These marshes, and this is a swamp, are kind of useless. So if someone says to me, Mike, a friend will say to me, I found a new wetland for you, I found a new wetland for you, you want to come core it? I said, is it a marsh or a swamp? Well, I don't know. How deep is it? Well, I don't know. Well, if it's a marsh or a swamp, I have no interest in it, because the peat at the bottom of it radiocarbonated 200 years. I can figure that out by looking at the existing vegetation. I don't need something like that. So here's a swamp. This is along the East Branch Delaware River, just north of Margaretville in Delaware County, not far from where I live. So swamps are not really any good. Okay, now we got a bog. This is a true bog. It's a peatland. This is Mud Lake. It's out near Oneonta. And in my catalog, it's over 362, but that doesn't mean anything to you. I've cataloged and studied about 125 peatlands in the Catskills in the last 30 years or so. So here's a peatland. This is a bog. We have a radiocarbon date on this one. It only goes back about 5,000 years at the bottom of this thing. And it took me until 2 years ago to figure out why. That was a whole mystery up to itself. And here's a fen. See, let me go back. Go back. A bog is usually an open place. Here's a pond, and here's bog mat vegetation. It's kind of shrubby and grassy, sedgy, with pitcher plants and sundews and so forth. Whereas a fen is more forested, like this. Your Bull Hill bog, my number 416, which is only a few miles north of here, is really a fen. There's a picture of it, 2 pictures of it right here, if you want to come up later, take a look at it. It's a forested fen. This one is spruce or hemlock, yellow birch with some shrubs. And if you dig down in this one, this is in Greene County, town of Windham. If you dug down in this one, you get the peat at the bottom of that would be maybe about this deep. And we'll go back, I forget for number 309, was it 8,000 years? And you say, oh, 8,000 years, that's a lot. Yeah, but it's only halfway back. I want to go back 14,000 years. 8,000 is not good enough. That tells me half the story. Okay. how do you get the peat out of the wetland? How do you get the peat out of the bog? Well, the shallow ones, you use a shovel. Here's my shovel, top of it. This is a shallow bog. Shovel's good enough. And here I am, all bent over, with my hand down in the hole which I dug with my shovel. There's the top of the shovel. And this is a kind of dirty, sweaty work with black flies. And you really get exhausted but filthy by the end of the day. And you're soaked and you're bitten by flies. And you're happy. You got your haul of peat. Here I am again, with my head almost down the hole and all my tools. This is a shallow bog. So what do you do when the bog is 5, 10, 15, 20, 30 feet deep? Well, you need this tool. This is a peat sampler, and you can screw onto the top of it an extension rod, like so, and I have 9 extension rods, and then on the top of that, is a handle. So you can work on the thing, pull it up and down. I brought only 1 extension rod with me. I didn't want to bring all 9. And those 9 extension rods, each one is a meter. So when you get 9 extension rods plus the peat kit sampler and the handle, you're down 10 meters, which is over 30 feet. And is that in focus, Lee?
Yeah.
Yeah.
Okay, see, for me it isn't. This is Wes Gary, the handle. He's a tall fellow, he's over 6 feet. And here are the extension rods, and the handle is way up on the top. That's how deep this bog is. It's about, we have about 5 or 6 meters, which would be about 18 to 20 feet, 16, 18, 20 feet deep. This one we got back only 10,000 years. But I want to show you what this looks like when we really have a deep peatland. Here's the handle, extension rod behind there, and Wes is pushing this peat sampler down into the peat, manually pushing it down. And here's what it looks like when it comes out. The peat's in here, which is, there's a little compartment in here. This is where the peat is in that compartment. And I'll show you what some of these peat samples look like shortly. So here's one. This is the peat. This is a 1/2 meter, which is about 20 inches. That would be, well, from here to here, it's a 1/2 meter, which is approximately 20 inches. And the peat sample is a cylinder, about 20 inches long, 2 inches in diameter. And I take the peat sample home. I have a little workbench, a little laboratory bench in half of my kitchen, and I can pull the fossil plants out of it, and then get them identified, and then the peat sample is sent for radiocarbon dating to a laboratory. This is a piece of wood, and it had not rotted. It's brown. The rest of the peat is more black. I'll show you more peat cores later, what they look like. Now this is Maple Crest Bog, which is in the town of Wyndham. And here's my crew helping me. And the peat sampler is down in the bog, or just at the surface, and we have 5 or 6 extension rods, and here's the handle way up in the air. That means that this distance from the ground level up to the top of that's how deep the bog is if you were to push down. It's about 20 feet. And this one, we did get a 13,000 year date on the bottom of the peat of this one. And you say, well, 13,000? Yeah, but Bow Hill is over 14. So, I mean, this is respectable. When they get up to 13,000, I get interested. Below 13,000, who cares? They're still youngsters. Okay, now, what can you learn from the peat samples? I've given you all the why bother with the bogs and how to go about doing it. But let me see what the time is running. Okay, because I want to allow at least about 8 or 10 minutes on this. So what can we learn from bogs? Well, one is, what was the vegetation like in the Catskills in the very earliest years after deglaciation, after the ice melting? Well, this bog, the Bull Hill bog here will tell us, because the radiocarbon date is so ancient. But this is Newfoundland today, the island of Newfoundland. And this is Arctic tundra vegetation. And this is so far north and high up above sea level and exposed. You can have some leftover snow, and this is summer. That the forest has never really conquered this vegetative site yet. This is what we call Arctic tundra. There's small dwarf shrubs, herbs, grasses, wildflowers, mosses, lichens, and here's a friend of mine who just recently passed. How tall is Ted? He's about 6 feet. So in other words, he's not a giant. He's a normal-sized person. So you get an idea how stunted the vegetation is. Well, probably the Catskills look something like this. Not the topography, but the vegetation probably looked something like this between 15,000 and 14,000 years ago, because I am not getting many woody plant fossils in the peat. That is, it's mostly small stuff, things like grasses and mosses and so forth, maybe a few small shrubs. So the Catskills could have been this open Arctic tundra vegetation for maybe the first 500 to 1,000 years. When I was a grad student, we were told that maybe in the northeast U.S. we had this extended long period of thousands of years, of millennia of Arctic tundra. Not the case. Within 1,000 years, the forest was here. And within about 1,200 years, it was here in full and all over the place. But more about that a little later. So we're learning a lot about the Catskills' past climate through learning about what the vegetation was here. Because the plants can tell you what the climate was like. Here's another picture of Newfoundland. Actually, this was Labrador, taken just a few decades ago. This is July. The ice and snow hasn't all melted. No trees except in protected pockets. This is Arctic tundra today, north in Canada. And probably was here in the Catskills about 14,500 years ago. If you looked out this window, it's probably what you would see covering these hills. Now look what's going on here. This is the Arctic tundra, these small dwarf plants. But look what's happening. Here's a protected ravine. Here's a protected ravine with a little valley. Those are balsam fir forests primarily. And look where they're growing. There's deeper soil down in there along that creek, and it's protected somewhat from the wind. So the forests are invading the best places to grow will be invaded first. And if you look at this mixture of Arctic tundra and what we call boreal or northern forest, this is probably what the Catskills look like. Yeah, 14,500, 14,000 years ago. Probably look like this. Not the topography, not the geology, but the vegetation. This is probably what we looked like if you were looking out this window 14,209 years ago. Okay, here's spruce fir forest in the Adirondacks. This is spruce fir forest on Algonquin, the Adirondacks, the boreal forest. We have northern hardwoods forest lower down. But I have found out in just the last decade or so that the spruce fir forests moved into the Adirondacks in a very different manner than they moved into the Catskills. But that's a whole other story and a whole other three credit college course. I'm not going to get into that. Here's red spruce. I think that's yours truly working on a sample plot up on Plateau Mountain. See, for you it's in focus, but for me, all right. This is a old growth spruce fir forest in the saddle between Cornell and Slide Mountains. Red spruce was in the Catskills by 13,900, 13,800 years ago. It was a little bit here at 14,000, but by 13,900, 13,800, 13,700, it's here. Here's balsam fir forest. Here's a graduate student. Look, his hair isn't even white yet, see? That's what we look like when we're grad students. He's going down Slide Mountain, which is the highest in the Catskills. Here's a balsam fir forest, and balsam fir was here 13,900, 14,000, 13,800 years ago. Not only that, hemlock was here. 13,900, 13,800, 13,700 years ago. What that means is that hemlock got here real quick. And not only hemlock, but yellow birch was here also 13,900, 13,800, 13,700. What that means is these trees, especially yellow birch and eastern hemlock, are not really northern boreal Canadian species. They're more northern temperate species. That is, they require a longer growing season and warmer temperatures. So that tells me that the Catskills had warmed up enough by 13,800, 700 years ago to support hemlock and yellow birch. So that climate wasn't that much different from what it is today. Could have been a little bit colder, about the same, a little warmer. In other words, some people think it took thousands of years for the Catskills to warm up to the point to support the forest that it does now. That's not the case. It warmed up pretty fast. By fast, I mean not 5,000 and 10,000 years, but more like 1,000. Trying to think what does this represent? Excuse me. I can look it up or just go easy. Okay. I forgot what this is supposed to represent. Okay, it doesn't make any difference. All right, we have ponds and lakes. Let me get to this. We're still working on that portion of the presentation where what have we learned from the bogs that otherwise we would never know. Well, we do have lakes and ponds in the Catskills. Some people say, oh, the Adirondacks are full of mountains and lakes, but the Catskills have no lakes. That's not true. We have a few. There's a concentration of them in Sullivan County in the northern part. And we do have a few in the Catskills. This is Long Pond down Sullivan County. And we have ponds. Which one is this? Oh, that might be 362 in Mud Lake near Oneonta. This is the town of Hoppersfield, Davenport, right on the town line in Delaware County. And there's a bog mat here with a bog pond, and there's black spruce and tamarack. This almost looks like the Adirondacks. And here's North Lake, the bog mat. And North Lake, of course, is still a lake. We still have some in the Catskills. And now something else. This is the top of Balsam Lake Mountain, the bog. There's no lake there, but there used to be. The bogs can tell us where there had been lakes and ponds that no longer exist, and there are dozens of them. I forget the statistics, but out of 125 bogs that I've studied, how many used to be ponds? It's got to be a third or a quarter of them, at least. In other words, I like to say that I like to call the Catskills the land of 200 lakes. You say, what? Well, where are they? Well, we used to have them. Well, what happened to them? Well, they've all grown in. They look like this. They're wetlands now with forests. But we used to have ponds and lakes by the dozens in the Catskills, which no longer are here. And Bull Hill Bog up here in Schoharie County is not an exception. It had been a popular lake. Well, how do you know that this was a lake or a pond at one time? Well, I'll get to that in a minute. Here's Bog 386, which is called Fairy Spring Bog. It's on the escarpment near South Lake, North Lake, where the Catskill Mountain House used to be. And this one had been a pond. And dozens of others, which look like this now, all filled in vegetation, had been ponds. So we used to have ponds and lakes in the Catskills. If we didn't have bogs, how would we ever know? We wouldn't. Okay, here's a core of peat that came out of, I forget which bog this is, probably South Mountain. But if you look here, this brown stuff is peat. And this black, gray stuff is silt. Silt is like sand, but much smaller microscopic particles. And the silt tells us that this was a lake bottom. You need quiet, ponded water that would accumulate runoff. This is in the very early years of the after deglaciation, when there wasn't much forest left. Excuse me, there wasn't much forest yet in the Catskills. And what would happen is that there'd be a lot of bare ground and bare glacial dump, which we call till, and that stuff would wash out the silt and accumulate at the bottom of the pond. So we have these layers of silt, and there's only one way that you get layers of silt and clay at the bottom of these bogs, and that is there'd been a pond there once, and the clay and the silt settled in the pond. So that's one way of knowing. Now does this show, here's more silt. The peat is brown, but the silt is more gray. So you have silt in some of these peat cores. How about another way to find out that we had a pond in this barn, and the pond is gone? A lot of ponds have gone 10,000 years, 9,000, 8,000, 5,000 years. Aquatic plants. This is white water lily, Nymphia odorata. More Nymphia odorata, white water lily. These are aquatic plants. This is a bit out of, not a good photo, but that's the yellow pond lily, or spadadoc. If you know your plants, Nuphar advena. Sorry for my Latin and Greek, but I'm a botanist, I can't help it. This is a sedge, which is a grass-like plant. It's known as a three-way sedge. Dolichium, that's a specific name on Dolichium. It'll come to me. Anyway, this three-way sedge grows in shallow water. And I find the seeds of this sedge, what do I have here? Yeah. I find the seeds of the sedge, which are very distinctive, have little parachutes on them, in many of the buds, in the peat. And that tells me not only that this had been a pond, but it tells me how deep the water was in the pond. Because this plant, this three-way sedge, grows in water that's usually from 6 inches to about a foot deep. So not only do I know that there is a pond, or was a pond, but that how deep the pond was. And you can actually see by the change of vegetation how the pond went from open water, deep water to shallow water, to shallower and shallower and shallow water. And then when the aquatic plants disappear, there's no pond at all. And that's what happened right here in Conesville. Here's a close-up of three-way sedge. The seeds in this plant are very distinctive, and they don't even rot. And when you find them by the dozen in the peat, you know right away that they had been shallow water. Okay, here's something else. Here's a wetland. This is down the Beaver. This is number 346 in my catalog. And there's hemlock growing in this wetland today. And here's number 319 up on Millbrook Ridge. And it's a friend of mine taking pictures up there. There's no hemlock in this wetland today. How far back does this go? 319 dates back to about 7,000 years, the oldest being at the bottom. And what do you find at the bottom of that? Where is it? Hemlock cone. It's about 5,500 years old. I pulled this cone out, it was saturated with water and closed. And then what happened was, I just left it out in my homemade laboratory, and the next day or two it had dried out and the cone scales opened up. That cone had seen daylight for the first time in 5,500 years. Now, there's no hemlock here today, but there was hemlock on top of Millbrook Ridge up until about 4,000 or 5,000 years ago. And this is not the only place. I've gotten about a half a dozen bogs that have hemlock fossils, but only fossils, which means that the hemlock used to be up there and is now gone. So that's another thing you can learn from bogs. Plants that used to be there, not just aquatic plants, but also trees. And in May, I think it's May 11th, Mountaintop Arboretum, Greene County near Tennessee. You're familiar with the Arboretum? I've got a lecture there on the history and ecology of hemlock. And I'll be spending a whole hour, oh, those poor people at the Arboretum, a whole hour on 15,000 years of hemlock history and ecology in the Catskills. And a lot of that will be on what the tanners did and what they didn't do, and how you can tell what the bark peel is found a few hundred years ago by looking at the hemlock forest today. And also places where the hemlock used to be and is no longer exists. Balsam fir forest, what was that supposed to represent? Oh, yeah. I did want to mention this. Top of Balsam Lake Mountain, dense balsam fir forests. You go down to Millbrook Road, and there's bog number 380. It's 2 miles from the top of Balsam Lake Mountain down to the road, with a drop of quite a bit in elevation. And that bog, it's barely 2 miles from the top of the mountain, has no fur at all in the fossil wreckage. In other words, you would think, well, look, the mountaintop has balsam fir up there. Maybe this bog down at the bottom of the mountain used to have fur and the fur is gone. No, there's not a trace of it. And not only in that bog, but in others. In the East Branch Delaware Valley, it's very, very rare to find any balsam fir fossils. That tells me something about how the fir and the spruce have migrated into the Catskills about 14,000 years ago, and in many places did not migrate through. So you have a bog here at the base of the mountain where there was no fir at any time. In other words, the trees, as they moved north, migrated in very narrow pathways or very narrow strands, if you look at a map, and missed places and went to others, and missed places and went to others. We'd never know that without the bogs. We'd never know that. Okay, peat cores. I hope this is going to be showing you that we're getting toward the end here, because I want to allow a little bit of time for that. I don't know how well you got to get really on top of this to see it. But in this brown peat, there are black layers. There are black layers. Well, you really got to get close to see them. You see here, you got to really get close. When the peat is fresh and coming out, this is inches. When the peat is just coming out of the ground, you can really see it. These are black layers. What are they? Okay, well, I've got some right here. It's charcoal. I got samples of charcoal. What is charcoal? It's burnt wood. How did it burn? Forest fire. We had forest fires very commonly throughout the Catskills for thousands and thousands of years. I get charcoal from the mountaintop Arboretum Emerald Bog that's back 13,000 some odd years. The consistent charcoal forest fires for going back 14, 13, 12,000 years and all the way through to the present. I just thought I'd show you a few pictures of contemporary forest fire. Here's a brush fire. Here's a brush fire. More serious, here's a fire that took place in the Adirondacks. What was the Vermont for a fire? 1991? Has it been 33 years? But I never got close to this one because the fire departments kept us away. But this was a fire in the Adirondacks, and a fellow who was a reporter from a newspaper let me have some of his slides. Underexposed, I'm sorry. But this was quite the recent fire. Oh my gosh, you really need a blackened room to see that. This is a recent forest fire, and here's the local fire departments trying to control it and save the houses and the people, which they did. Okay, last 4 slides. A little bit of comedy, and then I want to get to this, because I want to end a little bit after 2. Working in these peat bogs can be dirty, can be sweaty, can be wet, can be full of flies and being bitten. If I look grouchy and grumpy there, I am, but when you get home and you get all the plants identified and the radiocarbonates come in, then you're happy. But some of that work can be not the most comfortable. I wanted to show you this. Here's 307 on top of Dry Brook Bridge. See this little boy? About 8 years old. He's my attorney now. 307 was quite an inspiration to me just last summer. I was up there. I was using it to confirm an observation I made about number 303, which is this one. I don't even want to get into that. This is on top of Dry Brook Bridge. Notice there's no spruce and no fir. It's all hardwood. It's mostly yellow birch. You might say, oh, the spruce and fir forests were here 10,000 years ago and disappeared. They were never there. And I would have never known that without the bogs. And you might ask, oh, let's go back another minute about that. I should mention a little bit more about the fires. I think I had one more slide. Yeah. You might ask, well, who caused the fires? Well, there are 2 sources. One of them is Native Americans, and one of them is lightning. And I can sometimes figure out which is which, but right now I'm working on an inventory of a few dozen major historic forest fires in the Catskills. And if you try to categorize them into, these were caused by Native Americans, American people, and these were caused by lightning. It's very tricky. You can't be absolutely sure, but you can have a guess. And how you do it is, if it's Native American, it's going to be primarily starting about 7,000 to 6,000 years ago. Some of them are earlier. Primarily 7,000 to 6,000 years ago, where the Native American population increased rapidly in the Hudson Valley. And they burnt the Hudson Valley, and the fires went up the escarpment and burned along the crest of the escarpment in the Catskills. So a lot of the bogs along the escarpment are picking up charcoal bands that go back 7, 6, 5, 4, 3, 2,000, 1,000, a few hundred years. And when the Native Americans stopped burning, then the Europeans started burning up until roughly the year 1900. So if you're in an area where Native American populations were intense and busy, if it's less than, say, 7,000 to 6,000 years, if the forest is now dominated by oaks, hickories, chestnut, mountain laurel, blueberries, sweet fern, huckleberries, you can tell by the forest, it's Native American. If, however, the charcoal is in a bog that's in the interior of the Catskills, in the western Catskills, and the radiocarbon date on the charcoal is 10,000 years, or 12, or 9, and it's way up over 3,000 feet in the mountains, it's probably lightning, but I can't be sure exactly all the time which is which. In fact, one of the chapters I'm writing in the 6-volume second edition of the Catskill Forest History is on forest fires and charcoal. And at first I thought I'd have here all the lightning fires and here all the Native American fires. I'm not sure which is which. I better not classify them that way if I'm not sure. There are tendencies, you can guess who caused the fires, whether it was the lightning or people. Okay, I just brought this map along, just if there were any questions on geography, but I thought I would shut this down and talk to you about this, and then we'll be done. So, may I shut the projector off? I always worry, is this the last time that bulb will light? The bulb off?
Yes.
All right, let the fan cool it. Okay. Now, whoa, that's glare. I need my sunglasses. Okay, let me tell you about this. So let's sign around. I started, when did I start? A few minutes after 1? Have I got an hour? Not quite. Well, I'm used to 55-minute college lectures because the students need the 5 minutes to change classes. Anyway, in 2018, did Frank ever come here? I guess he's not here today. Okay. Frank is a friend of mine. He told me about this bog up in the town of Combsville, which is the first one I'd ever studied in Schoharie County. And the location, I've got some Schoharie County maps there. People know exactly where it is, and a sketch map. These came out of my actual field note folders. I figured, how am I going to display material on the Collinsville, or what we call the Bull Hill Bog, because I don't have slides on them. So how am I going to do it? I figured, well, let me make some posters. I didn't have much time. And these are actual copies of my field notes, different pages, and they show different things. And these photos were taken by one of my colleagues, who's, some of you know Dave, from the Natural History Preserve in Stanford. He took these pictures. There's yours truly probably having lunch or something there. This is a fen. It's now hemlock, yellow birch with an array of shrubs. It's forested. And this did once have a lake, but let me tell you what else it did have. Here's a map on how to get there. I very often do this on some of these boxes. The road network, how do you get to that place if you want to go there again? If someone wants to go see it, how do you tell them to get there? And then here's a more detailed diagram of the bog itself and where we took our peat samples. And then here are the cores. Here the peat sample, and this is peat sample is down here. That's its ground thing. It's in here. And this is down 1, 2, 3, 4 extension rods in the hand. So we're down 300 centimeters. That's 3 meters. It's not quite 3 meters. It's about almost 9, almost 10 feet. We're down. That's in the U.S. How deep is the deepest one? The deepest one is 417 in Sullivan County, town of Neversink, which we used all 9 extension rods to get down the bottom of it. Number 417. It radiocarbon dated at 9 meters to only about 9 to 10,000 years. It only took me the last 2 years to figure out why. You would think the deepest would be the oldest. It doesn't always work that way. And I couldn't solve that mystery until 2 years ago. So, things are still happening. In other words, I'm still making discoveries. If you think I understand it all, I'm a long way to go. But I'm getting there slowly. I took another peat sample, shallower, from 200 centimeters to 150. That would be down about, 200 meters, maybe down about 5 to 6 feet. The deepest one is down more like 10. And the oldest one, dated 14,883 years. That's plus or minus 30, so it could be 14,800. The second oldest radiocarbon date I was able to get in the Catskills. The oldest date came from Tannersville, the Mountaintop Arboretum, and wood log number 407. That was 14,900. This one is 14,800. So this is the second oldest radiocarbon date. So what was there at that time? Anyway, this diagram here gives me a little bit more detail on the samples and how deep they were. And this is a listing of the current plants, the current vegetation, what's growing there today, and other features, water quality features, acidity, temperature, things like that, and other features about the bog, physical and chemical features. And this is, to me, the most important part. This is the fossil diagram. So as you go back in time, you go down the bottom of the chart, and this is mineral material, roots, wood, stems, yellow birch, leatherleaf, blackberries and raspberries, pond lilies, pond weeds, hemlock and grass and sedges, and I have a spruce needle at 14,800. So there was spruce. There's no spruce there today, but there used to be spruce up there in Bull Hill Bog, about 14,800 years ago. I got 1 meter. So I wish I had more to confirm and make sure not contamination or something. And you might say, so these spruce anywhere near it? Yeah, but not in the bog, but north of it. I have maps, and distribution maps of red spruce that is still here in the uplands in Schoharie County. So there is some left, very isolated populations farther north. There's a place called 5 Point. And just north of that, there are a few places where you do have native red spruce. But here in this bog, 14,800, here's some other things, what was going on there at that time. I probably have some hemlock and some yellow birch, but I did another radiocarbon date, and I got, move over, wait a minute, move over. Come on. This is where you need a graduate student to hold things. We took another radiocarbon date from the peat sample, and about 2/3 of the way down, and we got a date of about 10,300 years. You might say, well, why did you date that one? Well, the reason is that's when the aquatic plants stopped. That was the end of the pond, because no more fossil plants of pond weeds and water lilies. They were gone by about 10,300. That means it was an open pond from 14.8 to 10.3, so what is that, 5,500 years it was a pond. And then the pond filled in with vegetation and no more pond. So you can tell all these things. Charcoal, I don't see any charcoal in here. So I don't have any forest fires, at least not in the sample I took. I think I'm going to stop. I went just around an hour, yes, no? So it's time for a cough drop and a nap. So shall I shut down? Yeah.
Did you ever find any evidence of pottery or arrowheads or bones or anything like that
No.
in the forest?
You mean from Native Americans?
Oh, yeah, I guess it would be.
No.
So no artifacts, all just vegetation material?
Well, why would the people throw that stuff into a wetland?
Well, because, I mean, you know, people move,
Well,
things get compacted.
You would need an archaeologist or an anthropologist for that kind of thing, but the answer is no.
Yeah.
And if you ask, how about animals? We do get occasional insects,
Yeah.
beetles, but No human artifacts like that, no.
Well, you know, I mean, in England, they found bodies in bogs, and they call them the bog man. People
Well-
have ceremoniously buried people in bogs
Well,
as
this
a
is a deep
preserve.
one, this is a deep one. But the average depth of a large casket, that's why you can't have a large mammal or human being, it's too shallow. So, no, I have. And I do, the story about beetle wings covers, that's a whole story into itself. But occasionally you find some insect remains. But other than that, I'm working with the plants. Yeah, hi, Alan.
Question, of the box you cataloged, how many do you think you've gotten in comparison to might still be there?
Wait a minute, say, wait a
Of the
minute.
box you cataloged
Wait.
in the Catskills?
Let me, if this is cool, let me shut it off. It's making a lot of noise. I can't see it. I have to go around. Where's the switch? Oh, what a relief. Now I can hear you.
Of the number you've cataloged in the Catskills,
125.
how many do you think still remain that you haven't had the chance or haven't come across or have?
Oh, how many do you think have not been studied? Well, I know there are quite a few dozen that are just too shallow to even bother with. But you dig down the peat is only this deep to glacial till, and it's not even worth it because if you get a radiocarbonate at the bottom, it's gonna be 200-300 years. And heck, I can use the present vegetation, tell me what it was like 200 or 300 years ago. I don't need a bar. Well, that article I did for Catskill Life a number of years ago, I said Catskills land of 200 lakes. So my estimate was maybe the 200. That was a kind of a conservative estimate. Depends on how you define the geographic bounds of the region. I go way beyond the blue line. I'm generally, my definition of the Catskills is pretty much where the hilltop accordance is at least 2,500 feet or more, and basically it's determined another way. But that's a whole way how to define the Catskills. That if you're in the Catskills, you can have mountains that have not been farmed to their tops, pastured to their tops. That's one of my definitions. Yeah. Yes.
Stand up. No, can you tell us exactly like where on Bull Hill that bog is? Can you give us an idea?
You want to come up here?
I will. I don't need to come up, I guess, I think all of us are wondering.
I have some maps here that I brought, and I'm looking here at my little sketch map from West Combs Hill. We go north on County Route 59, which is Bull Hill Road.
Right.
And you're passing a whole bunch of other roads, I don't know how to pronounce this. Looks like Hawkins, Robinson, Wood Road, Van Aiken Road, Roy Road. And then there's something that looks like Gherkin, which is now Bowling.
Bowling Road, yeah,
Bowling
Bowling
used to
Road.
be Gherkin.
Yep.
And it's just a little bit past that on 59. Park here and then head west. It's DEP land. It's New York City Environmental Protection.
Can you pass Bull
You want to look at my maps?
near place? Okay.
A friend of mine told me about it. He brought me in there.
Great, thank you. That helps a lot.
But as I said, really the big news about this one is that it almost broke the record of the oldest radiocarbon dating, second. And Mountaintop Arboretum is only 100 years older at the bottom.
Kim, do you mind if I announce
Yeah, go ahead.
our hike that we're doing?
You mean I stayed during an hour?
Yeah, we're doing some hikes this summer with the Gilboa Museum as fundraisers. And Mike and I are gonna be collaborating on a fossil tree descendant hike on top of Poland Hill in Gilboa. And he is going to help identify the moss, the ferns, the club moss, and I'm going to help parallel them to what the fossil trees were like. And that's August 3rd at 10 o'clock. I'm meeting at the, well, it's probably earlier at the museum. You'll see some paperwork on it. hopefully soon.